Hello and welcome to Chapter 5. And Chapter 5 is going to be taking a look at interpreting slopes equations and applications of linear functions. So we just finished Chapter 4 and we took a look at linear and a couple of nonlinear functions. Chapter 5 and Chapter 6 are going to capture the essence and the ins and outs and the nitty-gritty details of all of those linear functions. We cannot get into that, however, until we take a look at constant rate of change or slope with lesson 5.1. So here are the humongo big list of 8th grade standards that we are going to be learning now here in Chapter 5. And today we are just going to be touching on identifying those graphical properties of functions, including slopes of those functions. So what is slope? Here is a quick little overview of what it is and how we find it.
What's up, everybody? Let's go ahead and jump into this introductory lesson on slope. Now, what makes a roller coaster fun is that you are constantly changing direction, whether you're increasing or decreasing at different levels of steepness. And we are going to relate this experience to our understanding of the slopes of lines on the coordinate plane. So we are going to think of the slope of a line as its direction and its level of steepness. Now, portions of a roller coaster with a low amount of steepness result in a slow and gradual change in elevation, while the sections that are very steep result in a rapid change in elevation. So as long as you're not feeling too nauseous, let's go ahead and extend this thinking to our understanding of the slopes of lines. Now, in this lesson, we're going to discuss two types of slope, positive and negative. Now, positive slopes increase from left to right, while negative slopes decrease from left to right. We will also be referring to slope in terms of what we call rise over run. So we have a line with points on the line. Now the rise is going to represent how many units up or down we have to move. And the run is going to be how many units left or right we have to move in order to move from point to point. And it kind of makes this staircase image. Now notice that since this line has a positive slope, our rise was upwards and our run was to the right to move from point to point. However, if our line has a negative slope, that is, it decreases from left to right, when we rise downwards. I know that sounds weird, but we're rising in a downwards direction and then running over to the right to move from point to point. So let's take a few moments to visualize the difference between applying rise over run to positive and negative slopes. Again, notice that the line with the positive slope is increasing from left to right, and that the line with the negative slope is decreasing from left to right. Now we can go ahead and take a look at a line on the coordinate plane. Now we want to find the slope of this line in terms of rise over run. So our slope is going to be expressed as a fraction of two numbers. So our rise is the amount of change we go vertically. Our run is the amount of change we have horizontally as we move from point to point. Now this is a positive slope. We can tell by looking at it, it increases from left to right. And we're going to start with the two farthest points away from each other. So we'll start by counting the rise, the number of units that we are increasing, and then the run, the amount of units that we're moving horizontally, again, to make this staircase shape. If we count the number of units upward, we rose 12, and then our run was 18 units to the right. So we can express our slope as positive 12 over 18. However, 12 over 18 can be simplified. We divide those both by 2, we get 6 over 9. That means that if I start from the same point and this time rise 6 units and then run to the right 9 units, I'll still end up on the line. It's a different point. This is a more simplified slope, but if I repeat that by rising 6 and running over to the right 9, I do end up in the same spot. So when we find the slope of a line, we always want it in the most reduced form possible. Now 6 over 9 is smaller than 12 over 18, but that can actually be reduced again. 6 over 9 is equivalent to 2 over 3. Now we notice that if we start again at that same point, rise up 2 units, run to the right 3 units, we end up at another point. This time it's the closest point. And if we continue that pattern by rising 2 and running to the right 3, we're slowly building that staircase, but we're also landing on a point on the line each time. So the most reduced form of the slope of this line is positive 2 over 3. Now again, that doesn't mean that the other two slopes, the 12 over 18 and the 6 over 9, were incorrect. They just weren't in reduced form. But all three of the slopes that we looked at will take you from one point on the line to another point on the line. So here's our first example. We want to find the slope of the line that passes through the given points that are shown on the graph here. Now we know that slope is rise over run, so we want to find the rise over run between those 2 points. So let's go ahead and build our staircase. This line has a positive slope, so I'm going to rise up a certain number of units and then run over to the right to get from point to point and then count. My rise is 6 and my run is 3. Now I'm almost done, but 6 over 3 can be reduced because 6 divided by 3 equals 2. And we want to think of slope as a fraction in terms of rise over run, so we're going to express it as 2 over 1. So if we go back to the starting point, if we rise 2 units up and run to the right 1, we end up on the line again. And if we continue this rise over run of up 2 and going over to the right 1 and building that staircase, we continue to land on points that are on the line. So the slope of this line in reduced form is 2 over 1, which we are just going to express as 2, since 2 over 1 means 2 divided by 1, which just equals 2. This last example is just like the last one, except now we're dealing with a different line. Now notice that this line decreases from left to right, so its slope will be negative. So now we want to find rise over run between those 2 given points. Since the slope is negative, we rise downward, and then we run to the right to make that staircase image. And then we can just count. So the rise downward was 3 units, and the run to the right was 8 units, so the slope of this line is negative 3 over 8. Which cannot be reduced, so that's going to be our final answer, the slope of this line.
Okay, so what we're going to do is we're going to take a look at our Chapter 5 intro note sheet. And let's jot down some of those vocabulary words and ways to say slope. So notice he defined slope as just how fast a line increases or decreases with that roller coaster reference there, and he also refers to it as steepness. Now how you find slope is we calculate rise over run, and what that simply means is you're finding the change in your y value, change in your y-axis, and then you're going to divide that by your change in your x. This is a rate, so we're just comparing upward motion compared to sideways motion. Or we're finding the difference between, or the ratio between, a vertical change and a horizontal change. So go ahead and pause the video right now and make sure that you have those vocabulary terms written down, because we will be using these throughout chapters 5 and 6. So on the bottom of that introductory worksheet, our note sheet, we're going to find the slope of the line passing between the points 3, 3, and 5, 6. Now notice when you're finding the slope on a graph, and he did this too, we found points that are right on even intersections, so 3, 3, and 5, 6. You don't want to try to figure out, okay, this is like about 3.6 and up 4 type of a thing. So if you can find those intersections, so you're counting boxes and you're counting whole units for your rise and your run, that's going to make life a lot easier. So find those perfect intersection points on the grid lines and then count your rise and your run. So here we're going to rise 3 because the difference between 3 and 6 on my y is 3, and we're going to run over 2 because the difference between 3 and 5 on my x is 2 units. So this slope would be 3 over 2, and what we're going to do with these, because we want to see that ratio, is we're going to leave that in simplified improper fraction form. We are not going to change these to decimals. We are not going to change these to mixed numbers. We are done with 6th grade math. We are going to be taking a look at this rate or this ratio, so we're going to leave them exactly like this. So now let's take a look at our 5.1 note sheet, so lesson 5.1, and get some of these examples written down. The first example is finding the slope between -3,0 and 3,2. Again, find those perfect intersection points, -3,0 I've got with a purple dot, and then 3,2 with a blue dot, and then count your rise and your run. So I'm going to go rise 2 and run 6, which gives me a slope of 2/6, and then simplify that 1/3. So I could have found the slope between -3,0 and 0,1. I could have risen 1 here and run over 3. This is a positive slope because it is increasing from left to right. On the second example, we are going between -2,2 and 0,2. So again, find those nice intersection points, and I'm going to rise down 4. So my rise is a -4, and then I'm going to run 2. All right, and if I do -4/2, I could have gone from -2,2 down to -1,0 as well. I could have risen -2 and run 1. So -2/1 is your simplified slope, or you can just write it as -2. This one is negative because it is decreasing from left to right. So please make sure on your side margin of your note sheet that you write down the difference between when you can recognize when a slope is positive, when we go up from left to right like you're reading a book, and when it's negative, when you're going down from left to right like you're reading a book. So now let's take a look at the slope between -2,1 and 1,1. This is a horizontal line. Okay, now with that horizontal line, think steepness. All right, there is no steepness. We're not increasing, we're not decreasing. So there is no rise. Our rise is actually 0. And between those 2 points that I gave you, we are running 3. 0 divided by 3 is 0. So the slope of every horizontal line, because it doesn't have any steepness, it's not increasing or decreasing. Just think about like walking on flat ground. There is no slope or steepness of flat ground. It has a slope of 0. So think no slant with that. And another special case is when we take a look at a vertical line between -2,2 and -2, -3. So I've got those dots there. Now my rise between those points is 5 or -5, depending on which way you want to go. But then my run is 0. Now if you remember anything about dividing by 0, you can't. In fact, if you try to type in 5 divided by 0 on your calculator, you're going to get an error message, or the error syntax, or undefined, or something. So there is no solution to 5 divided by 0. This is what's called an undefined slope. So think ski slope or steepness of a ski slope. That is not possible to ski. That's like a cliff that you would fall off. So we don't say no solution. What we do say here, though, is we say it has an undefined slope. So make sure you write that word down. If you have a vertical line, every vertical line is going to have what's called an undefined slope. So we're going to actually use that word undefined, and because it's impossible to divide by 0. So increasing, positive slope, increasing from left to right. Decreasing from left to right is a negative slope. A horizontal line has no slant or no slope, and then something that's impossible to ride on or walk on, that has an undefined slope. So those are the directions that you need to remember as you are working on your slope practice for today.